joining me. If you were here last week, welcome back. If you're joining me for the first time, please do click the subscribe button. I think it's on this side. Click the subscribe button. Also click the notification bell so that you can get notifications whenever I post a new video. Also, please do leave your comments and like and share. So this week what we're going to be doing is we'll be doing functions. I think I did mention this in the last week's video that we'll be doing functions. So guys, please do stay tuned in. Don't forget to like, comment, subscribe, and also I'll link my email on the description box so that you guys can send me your questions and so that you guys can communicate with me, interact with me on the comment section so that I know if you do enjoy the content that I do here. And if there's anything that you have queries or questions and anything like that, do comment in the comment section. I'll be sure to respond to all of your questions. Thank you so very much, guys. I hope you enjoyed this video. See you next week. This question paper was extracted from the February-March 2016 paper, and we're doing question 4. As you can see, it's functions, and this is an exponential function. Just by looking at the function itself, you can tell the equation of the function. You can tell that it's an exponential function. So what we're asked to do is to calculate the equation of the y-intercept. As you can see, guys, I've already started. And when you calculate the y-intercept, you make your x to be equal to 0, and then you go ahead and substitute in the formula. So that's what I'm doing right now. And I've substituted, and any number, when you raise it to the power of 0, it becomes 1. So I get that to be 1, and 1 plus 1 becomes 2. And so that's like the y-coordinate of my x-intercept. Of my y-intercept, sorry. So I got my y-intercept to be 0 and 2. Moving right along, we're going to 4.2. So what you guys can do in the meantime is to go back and view the question from the previous clip or whatever. You can just go and view it and then pause this video and then maybe probably take it down and then continue so that you are not left out. So what I'm doing now is I am going to sketch the graph. That's what the question says. We're supposed to sketch the graph. And I already said that it's an exponential function. You can tell by looking at the equation that it's an exponential function. And I'm going to use the intercepts I calculated previously. And obviously I'm going to need like a line of asymptote, which acts as it restricts the graph. Basically, that's what it does. Yeah, so what I'm going to do right now, I'm just going to try and calculate the asymptote. So yeah, the asymptote, we define it as a line that restricts the graph in such a way that the graph approaches it but it never really touches it. So g of x is equal to, basically that function g of x is equal to 2 to the power negative x plus 1. So what I normally do is I take my calculator and I just keep on substituting values for x, and then I can see, like, I just want to see the behavior of the graph. I can maybe substitute 1 up to 5 and then just to see. But like, if you want to go further, you can go. So what I did here, in order for me to get that it's up to 40, when I got to, I just kept on increasing and I saw that it's 1 point something. So I just saw that it approaches 1, and when I got to 40, I saw that y is equal to 1. So that then gave me the clue that my intercept is, yeah, it then gave me the clue that my intercept is 1. Okay, wait, what? Yeah, guys, so that's my asymptote. It's y is equal to 1. As you can see, I hope you can see how to calculate the line of the asymptote. So moving right along, we're going to be doing question 4.3, which is to calculate the average gradient. So we define the gradient as the slope. So you calculate the gradient by, I'm just going to show you right now. I'm sorry that the camera is a bit shaky, but just try to zoom in so that you guys can get the footage. So we're given that we are supposed to calculate the average gradient. If you go back to the question, you'll see average gradient. Calculate the average gradient f of x, and we're given the points where x is -2 and when x is equal to 1. So f of x is equal to 2 to the power -x plus 1, and then you substitute first the -2 which we were given, and then you just punch that into the calculator. I mean, it's not that hard, guys. I'm sure at this point you can obviously punch that into the calculator and get the answer. It's just like that. Okay, so I got my answer to be 5. Then moving right along, you substitute again the other point that you were given, that x is equal to 1. So now we have f of x is equal to the power -1 plus 1. So I got my answer to be 3/2. Yeah, guys. So then now what I'm doing is I'm just writing the points that I'm just extracting the points from wherever, like, so you can see that when my x was -2, I got 5, and for the second one, when my x was 1, I got 3/2. So yeah, that's basically that. I hope you guys understand. So now I'm actually going to calculate the gradient. In order for you to be able to calculate the gradient, you need at least like 2 points in that same line so that you can be able to know the slope of the line. So when you calculate the gradient, you use the equation change in y over change in x. So what that means is y2 minus y1 and x2 minus x1. So x1 and y1 you will get from the first point, and x2 and y2 you will get from your second point. So what's the most important thing here to do is to just be consistent. So as you can see, I'm labeling all my points so that I don't get lost. I first labeled that one as x1 and y1, x2 and y2. So now it's just a matter of substituting whatever you have. You just have to keep that consistent. If you chose that this point is 1, you just keep on substituting it as 1. So 3/2 minus 5/1 minus -2, because be very mindful of the signs, you guys. You can get it wrong. The final answer you can get wrong, but like, okay, obviously I was playing myself, tried to zoom in, but hey, anyway, you guys, if y'all have access to the good resources, please donate, because clearly I need to have that app where you can show the calculation on the screen. So yeah, I got my answer as -7/6. So the next question is 4.4. As I said, you guys can go back and just view the question and then you can come back. So what we're asked to do here in the question is h of x is equal to 3 times f of x. So what this means is that if you had a function h of x and it was like 3 times f of x, then what would be your asymptote? Essentially, that was what the question was asking. So now you're supposed to, we do know that the asymptote of f of x was equal to 1, right? We can trace back that it wasn't so long ago. So yeah, guys, you can see that. So f of x is equal to 1 and h of x is equal to 3 when h of x is equal to 3, and then you substitute the 1, obviously, because that was the asymptote for f of x, and then you got your answer is 3. So then you have to like write your conclusion or something. It usually gets you like marks. So since the asymptote of f of x is equal to 1, therefore h of x is equal to 3. Yeah, you just multiply the two and then you get the final answer. I hope you guys understand. So this question paper was extracted from the February-March 2016 paper, and we are still doing functions just to give you guys like more, so that you can like have options and to have like a little more to practice on, because that's key. You need to practice. So here we're given equation g of x is equal to 6 over x plus 2 minus 1. So what I'm doing here is I just wrote the equation in this general form, that is g of x is equal to k divided by x plus p and plus q. So what k is, I'm just going to explain it. K is just a constant, and p and q represents the equations of the asymptote. So p would be your horizontal asymptote and q is your vertical asymptote. So for the vertical asymptote, that is your q, you just take it as is and along with its sign. And for the horizontal asymptote, you first need to like equate it to 0, and then you take 2 to the other side like I'm doing, and then you can, yeah, basically you can see that x is equal to 2, and then you put it back, because when it's like that, it counts as if we're in a bracket. So you have to, yeah. So I found that p is equal to -2 and q is equal to 1. So that is my vertical and horizontal asymptote. So the next question I'm doing is I'm calculating 4.2 from that question paper. So I said, you guys, you can always go back to view that, and yeah. So for question 4.2.1, we are calculating the y-intercept, which is you equate your x to 0. And then I'm just writing the equation, g of x is equal to 6 over x, which I substituted 0 in this case, plus 2 minus 1. And then I'm just going to punch that into the calculator and get the answer. It's that simple, guys. So I got my answer as 2. Now what I'm doing is I'm just going to write out the y-intercept. So my x was obviously 0, and then y is 2. So moving on to 4.2.2, we're asked to calculate the x-intercept now. So when we calculate the x-intercept, it's like vice versa. You make your y to be equal to 0, and then you can calculate for, yeah, you can calculate your y. So what I'm doing here, I just wrote the equation equated to 0, took 1 to the other side, and then cross multiply everything. Cross multiply the 1 and x plus 2, and then, yeah guys, I think you can see what I'm doing here. And then take 2 to the other side, which is you minus 6 minus 2, get 4, and then x. So my x is equal to 4. Then I write it out. The x-intercept is going to be 4 and 0. So the next question is 4.3, and if you go back, you'll notice that it says in the question we should draw the graph. So what I'm going to be doing now is to just draw the graph of g of x. If you notice that g of x is a hyperbola, so you can tell by looking at the equation that, like, the type of equation it is, you already know that it's going to be a hyperbola. I'll probably do a separate video where I like explain to you guys and just show you guys how you can actually tell that this type of an equation is going to come out from this and all that. but I just don't know if I'm over explaining things or something like that. But like, I don't want us to know, because that's why you're here, isn't it? You're here for help. So what I'm doing right now is I'm just drawing the Cartesian plane to a scale of 4. I'm obviously going to take the intercepts that we calculated previously, that is the X and the Y-intercept, which was 4 and 0, and 0 and 2. So P and Q, if you still remember, represent the equation of the asymptote. So your P is your horizontal asymptote and Q is the vertical asymptote, which was -2 and -1. So then I'm going to go ahead and just draw a dotted line. You indicate an asymptote by drawing a dotted line, and I'm also going to draw a dotted line for like the vertical asymptote as well, and try to navigate where my X and Y intercept are. Make a point there for the Y and make a point for the X. Then just simply draw my graph. We know that a hyperbola has like 2 arms, so that's the most important because that's the one that intersects the line. The rest, the other one, is not really important. You just draw it based on your asymptotes. You are guided by the asymptotes not to go over. Yeah, guys, so that's...
No role models and I'm here right now. No role models to speak of. Searching through my memory, I couldn't find one.